Hey guys! Today we're going to talk about expressions, parts of expressions, and how to evaluate a variable expression for different values of the variable. First, let's define it. Expressions. An expression is a mathematical statement that contains numbers and operations. Numbers are probably given, but operations are things like adding, subtracting, multiplying, dividing, raising something to a power, etc. An algebraic expression is an expression, just like the others, but it contains at least one variable along with numbers and or operations. Let's take a look at some examples of expressions, algebraic expressions, and things that aren't really either. First, let's start with expressions. The following is an expression because it includes numbers and operations. Here, numbers and operations. It's asking you to evaluate the power. And numbers and operations. When we move to the algebraic expressions, you'll notice that now we have variables in place of those numbers. So we have numbers and operations and a variable. Here we have a variable and a number. And here a variable is included with operations and numbers. Now some non-examples of expressions is just a y, that's a variable. 25, that's just a constant. And the addition symbol, that's just an operation telling us what to do with some numbers once we have them. All right, let's talk about parts of expressions. So we're going to use this expression for our example, and first we're going to find out what a coefficient is. A coefficient is a number which multiplies times a variable in an algebraic expression. So in this case, 2 and 4 will be our coefficients. Now notice that it doesn't say to multiply between 2 and the x or 4 and the x, but when you see a number-letter combination written side by side, and there's no operation indicated, we assume multiplication. So the way to read this expression is 2 times x to the third power plus 4 times x minus 7. Another part of an expression is a variable. A variable is a symbol, usually a letter, that represents a number. In this expression, x is used as a variable 2 different times. We don't know what the value of x is unless we give it to you, or you solve for it. A constant is a quantity that has a fixed value that doesn't change. In this particular expression, the only constant is the number 7. And a term is one part of an algebraic expression that may be a number, a variable, or a product of both. Terms are separated by addition and subtraction. So in this case, 2x to the third, that's one term. 4 times x is a term. And 7 is a term. Notice that they're all separated by addition and subtraction signs. All right, why don't you try? Using this expression, find all the coefficients. Remember, you can pause the video to try it on your own and come back to see if you were right. The coefficients in this particular expression are 7 and 6 because both of them are being multiplied by a variable expression. All right, using that exact same expression, see if you can find all the variables. Y and x are both used as variables in this particular expression. All right, this time we're using that same expression, but we want to find all the constants. Well, there's only one constant in this particular expression, and that is 23. All right, now you try. In this particular problem, this time we want to find out how many terms are in the algebraic expression. Remember, you can pause the video at any time. So in this particular expression, 7y squared, 6x, and 23 are all terms. They're all separated by adding and subtracting signs. So there are 3 terms in this expression. All right, now let's talk about evaluating expressions. To evaluate or solve an algebraic expression, you substitute a number in place of the variables and then find the value. Here's an example. If A is equal to 10, B is equal to 3, and C is equal to 5, evaluate the following expression. B plus 18. So first we have to identify the variables. B is our variable in our expression, and its value is equal to 3. So in place of B, we're going to place a 3, and the expression becomes 3 plus 18. When you add 3 and 18, you get a total of 21, and that is the value of that expression when b is equal to 3. Here's another example. Again, if a is 10, b is 3, c is 5, we want to evaluate the following expression. 4a divided by c. You'll notice that in this expression we have two variables, a, which is value of 10, and c, which has a value of 5. When we substitute and rewrite the expression, the a turns into a 10 and the c turns into a 5, and everything else remains the same. Then we'll use the order of operations. Well, we have multiplication and division in this problem. They are a group, and we do them from left to right. So we'll multiply 4 times 10 first to get 40, and then we'll divide by 5, so that the value of this expression when a is 10 and c is 5 is 8. Notice that the value of this expression would change if we changed the value of the variables. All right, here's one more example. If a is 10, b is 3, and c is 5, let's evaluate this expression, b squared. So again, b is the variable that we need to replace, and we know from our information that b is equal to 3. So in place of b, I'm going to place 3. Now this expression is 3 squared, and 3 squared means 3 times 3, which is equal to 9. So the value of b squared when b is equal to 3 is 9. All right, you try. In this problem, if x is equal to 2, y is equal to 25, and z is equal to 8, we want to evaluate the following expression, which is 3z. Now remember that when you see a variable and a number side by side, and there's no operation indicated, we know that it's multiplication. So this means 3 times z. Z is the variable we need to replace, so we replace it with an 8 based on the information that we have. So this becomes 3 times 8. And again, I'm pointing out that the dot is a multiplication symbol just like an x is. And 3 times 8 is 24. So the value of 3z when z is equal to 8 is 24. All right, try this one. Again, if x is equal to 2, y is equal to 25, and z is equal to 8, evaluate the following expression, y minus z plus x. So we've got 3 variables in this particular expression. We have a y, which is equal to 25, a z, which is equal to 8, and an x, which is equal to 2. We're going to replace each of those variables with their corresponding values. So y is 25, z is 8, and x is 2. Notice that the operations stay the same. We're just replacing the variables. Then we're going to use the order of operations. Well, addition and subtraction are a group from left to right. So we'll do the subtraction first. And 25 minus 8 is 17. Then we'll add the 2 to get a grand total of 19. So the value of y minus z plus x when y is equal to 25, z is equal to 8, and x is equal to 2 is 19. All right, how about trying this problem? Again, x is 2, y is 25, and z is 8. Evaluate the expression y to the x power. First, we have to identify our variables. We have a y, which is 25, and an x, which is 2. That means that this expression will change into 25 to the second power. That means 25 times 25 for a grand total of 625. So the value of y to the x when y is 25 and x is 2 is 625. Here's our last one. If x is 2, y is 25, and z is 8, evaluate the following expression, w to the 0 power. You might recall that we don't have a w in our explanation at the top. It doesn't give us a value for w. But you also might recall that anything, no matter what it is, to the 0 power is equal to 1. So even though we don't know the value of w, we know that whatever w might be, when you raise it to a 0 power, you get 1. All right, here's a quick summary of what we've learned about expressions. An expression is a numerical statement that contains numbers and operations. An algebraic expression is an expression that contains at least one variable, along with numbers and operations. A coefficient is a number which multiplies times a variable in an algebraic expression. A variable is a symbol, usually a letter, that represents a number. A constant is a quantity that has a fixed value that doesn't change. A term is one part of an algebraic expression that may be a number, a variable, or a product of both. Terms are separated by addition and subtraction. When you see a coefficient and a variable side by side with no operation listed, you assume multiplication. And finally, to evaluate or solve an algebraic expression, you substitute a number in place of the variable and then find its value. Hope this helps you understand more about expressions